Hello everyone, welcome back to MrMiers Math Channel. Today we're going to get into Chapter 7, which mainly talks about rationals and exponents. And in Section 7.1 today we're going to talk about nth roots and what nth roots are, and then also how they're directly related to rational exponents. Alright, so let's get started. Alright, first, one of the most important things in this section is we need to know how to use the calculator in order to evaluate some of these rational exponents. So one thing, if you're using a TI-84, TI-84 plus or any other of those types of additions, you're going to press the math key, okay, which in here is located by the red button, and then followed by the 4 key. Okay, this is going to give you a cubed root. All right, if you wanted any other type of root, you could press 5. So that's where it's got the x. Now, in order to do that, what you'd have to do is type in what root you're trying to find first, and then you'd type in, that symbol. So then it would give you the 5th root of whatever you're trying to find the 5th root of. Okay. If you're using other types of calculators, there's so many different types of calculators available that I can't give clear directions on every single type of calculator, but other types of calculators that are commonly used would be like the TI-30XS, the multi-view or the second edition. To enter any root higher than 2, you could just hit the second button, which is located in the top left corner, then followed by this caret symbol. All right, that's going to raise it to, whatever power. That caret symbol raises it to whatever power you want, but when you press second before hitting the caret, then you get that nth root button. Okay, so if you wanted to type the cube root of 27, for example, you'd hit 3 to specify what type of root, and then second caret to get that cubed root there, and then of course 27 equals, and you would get your answer, which in this case would be 3. And we're going to use this quite often. The cubed root of 27 is something that we're going to use very often, and we're going to see that over and over again throughout different lessons. All right, so in example 1, we're just going to use our calculator for both example 1 and example 2. So really, I'm just going to write down the answers. You just verify whether or not you get the same thing. Obviously, if you don't get the same thing, then you're not typing in the correct thing in order for the calculator to evaluate that expression. Okay, so the cubed root of 64 is just 4. The 4th root of 625 is 5. The 5th root of negative 243 is negative 3. And then the square root, notice that there's no number there. It's implied that that number is 2. Okay, so the square root of 225 is 15. Once again, just double check and make sure that you're getting the same values. All right, otherwise, you're going to have to, maybe Google a question how to use your calculator. Just type in the model of your calculator and then type in the specific question that you're asking. All right, let's get to the next example. Once again, same kind of thing. I'm going to write down instructions on top as to how you would type in part A. So part A is pretty darn simple. You could type in 625. And we're going to raise this to the 1/4 power. So to raise it to a power, that's that caret button. And then we want to raise it to the 1/4 power. Okay, so that's a fraction. Depending on the type of calculator you have, you might type in fractions differently. One tried and true method that pretty much works for everything is just writing 1 divided by 4 in parentheses and then hitting the equals button. All right, whether it's the TI-30XS multi-view or the TI-84 or any other addition, for the most part, that will work. So that's the thing that I advise. The TI-84 also has a fraction button in the functions, so you can mess around with your calculator and figure that out as well. So once again, just double check and make sure that you have the same thing as I'm writing down. So 625 to the 1/4 power is 5. 100 to the 1/2 power is 10. 512 to the 1/3 power is 8. And then 16,807 to the 1/5 power is 7. Okay, one thing that you might have noticed between these two examples is part A here in example 2, and then on the last slide, and I got to keep the text here with the software that I'm using, part B. Okay, so part B and part A both yielded 5. And I'm just going to rewrite this. Okay, so 625 to the 1/4 equaled 5. And then when we took the 4th root of 625, that equaled 5. So it appears that maybe there's some kind of connection between those two things. Okay, and the next couple examples is we're going to figure out what that connection is. So it seems like rational exponents, which is just fractional exponents, and these nth roots are somewhat related. Okay, and in the next slide we're going to see how. All right, so we don't have to use a radical to write an nth root of a. Okay, so this would be the nth root of a. We could actually use a rational exponent. All right, so we can rewrite this nth root as an exponent, where our exponent is just going to be our fraction. So notice some similarities here in each one of these is that the index of the radical, all right, is the denominator of our fraction. Remember right here in the square root of 3, the index would be 2. That's implied. And the denominator is 2. For the 3rd root of 7, the index is 3, the denominator is 3. All right, so that's one similarity that we see. Also, each one of these are also implied to be raised to a power. Each one of these is being raised to the 1st power, and that's where we get our numerator. Okay, so whatever power it's being raised to goes on top of the fraction. Whatever the index is, goes in the denominator of the fraction. All right, and that's how we're going to rewrite these. So we're going to just practice rewriting these, and this is going to be really quick. So like I was saying before, the cubed root of 2 is just 2 to the 1/3, and then just using our rules for exponents, we know that when we have a power rule, we have a power to another power, we'd multiply those exponents, so we would get 2 to the 4/3 power. That just allows us to cut to the chase and get right to rewriting this expression. Okay, so let's go to the next example. So in example 3, we're just going to rewrite the expressions using rational exponents. So we're going to translate this radical into a rational exponent. So in order to do that, like I was saying before, whatever we're raising this to is going to go in the numerator of the fraction, and whatever the index is going to be in the denominator of the fraction. So the fourth root of 5 cubed is just going to be 5 to the 3/4 power. All right, for part B, similar thing. We just take a look at what's inside the radicand, all right, and that's going to be raised to this 2/5 power. All right, what's on top, or what we're raising this to, goes on top. Okay, just think about it. We're raising it, so that's going up to the top of the fraction. All right, in part C, one thing to note is what is being implied here. What is the number here? Because it's not nothing. This is the square root, so that index is 2. So this is x to the 5/2 power. Awesome. Let's take a look at some more challenging examples. All right, so once again, part A might not be that challenging. We know that the implied index there is 2, so this is a to the 7/2 power. All right, for part B, notice 6b is inside the radical. So it's 6b that's the radicand there. We need to state that this whole thing is being raised to the 5/3 power. So that needs to be in parentheses. All right, if we just said 6b to the 5/3, then what we're saying is only b is being raised to the 5/3 power, and that's not accurate. Same thing for part C. All right, 5x is what's the radicand here. All right, that's what's in the radical. And this should be raised to the 7/2 power. Okay, so we know how to rewrite nth roots as rational exponents, but now let's go the other way. All right, so now we're starting with the rational exponent, and we need to rewrite it as a radical. All right, so we just have to reverse everything that we just did. Okay, so the denominator is the index of the radical, and then of course the numerator is what's on top, so that means that's what we're raising this thing to. So it's going to be the 5th root of 7 squared. 2 is on top of the fraction, so that's what we're raising this thing to, and then 5 is on bottom, so that's the index. Same thing over here. All right, so 2 is on top, so that means that's what we're raising this thing to, and then 3 is on bottom, so that's the index. So I always start out by writing the radical first with its index, and then writing what we're raising this thing to. All right, now notice 8x is in parentheses. That means that whole thing has to be in that radical. And this one's kind of simple because it's implied that this is being raised to the first power. Okay, and then also it's implied that the index of the radical is 2. I mean, you could certainly write the square root of 8x like this, but it would be a little redundant. It's not wrong. Mathematically, it's correct, but it's just redundant. Okay, so we don't need to. So we might as well write it like this. In part D, same thing. We have the 5th root of a to the 6th power. Awesome sauce. Now, that's a lot. That's a lot of rewriting. Obviously, we want to get to why are we doing this? What is this for? This would be for solving equations. That's what we're building up to. Okay, so in order to solve an equation, we might have to evaluate expressions like these. All right, so we could simply do this in the calculator. I mean, we could type in 27 raised to the -4/3 power and just make it a fraction. Hit enter. Okay, and that would give us our answer. Now, in this case, it gives us a decimal. Okay, and normally, okay, in most classes, they're going to want to write, they're going to want you to write that as a fraction. So that's not ideal. Of course, we can get that decimal into a fraction by hitting this button on the calculator. All right, if we're talking about the TI-84 calculators, you just hit math, enter, enter, and then you change that decimal into the fraction. And vice versa, fraction into the decimal. But if we're using other calculators, you know, some of them have a button like this, D to F with like a double arrow here. That just means it turns decimals into fractions and fractions into decimals. All right, we could do that, or if we remember, you know, how to rewrite these things, and if we remember a little bit about exponents and radicals, we could also just do this in our head, which is what I opt to do. All right, so first I'm going to rewrite this. So this is the cubed root 27 raised to the -4th power. Now the cubed root of 27 is something that we've seen before. All right, that was the very first one that we talked about. That was the one that I said it's going to come back over and over and over. The cubed root of 27 is just 3. Now the cubed root of 27 is 3 because what we're trying to figure out is what number could we multiply 3 times and get that number. And we could do a bunch of trial and error and we'd get 3. Now from here, 3 to the -4th power, if we remember our exponents chapter, which was chapter 6 for us, we got to get rid of that negative exponent. So to do that, we just put it on the other side of the fraction bar, which would be the denominator here. So we have 1 over 3 to the 4th power. And then we could just multiply 3 4 times, and we'll get 81. So this is just 1 over 81. So that decimal that you would have gotten if you did it in the calculator is just 1 over 81. All right, let's take a look at 2. I'm going to cut out a lot of what I was saying before so that I'm not being very redundant. So first we rewrite it as the 4th root of 81 to the -1st power. After that, let's figure out the 4th root of 81. That would be 3. And then we have 3 to the -1st power, which is 1/3. An example in part 3, we would rewrite it. So the denominator is the index What's on top is what we're raising this thing to. So we have the fourth root of 625 raised to the negative first power. The fourth root of 625 is something we've already done. That's 5. And 5 to the negative first power is just 1/5. For part 4, all right, the square root of 81 raised to the negative first power. Now the square root of 81 is 9. 9 raised to the negative first is 1/9. So you can see it's not that bad. It's necessary for what we're going to be doing next, which is solving these equations. But it's not too bad. We may need to rewrite it. We might have to do some more, some other algebraic things in order to get our expression or our solution at the end. Oops. Let's check out the next one. This is our first solving one. Okay, we might skip some coming up here, but we're going to do these two. We have x to the fourth equals 81. All right, what we're going to have to do is we got to get rid of that exponent. Okay, what undoes the fourth power is a fourth root. All right, they're inverse operations. So that means we're going to take the fourth root of both sides. And the fourth root of 81, like we saw before, was 3. But 3 is not the only thing that we could plug in for x and get 81. 3 to the fourth power is 81, but also negative 3 to the fourth power is 81. So our solution is actually positive and negative 3. So this is much like our quadratics that we've solved before. In part B now, to get rid of the third power, we're going to take the cubed root. Now, of course, we know that the square root of negative 8 would yield a non-real solution. But in this case, we have the cubed root. There is something we could multiply 3 times and get negative 8. And that's negative 2. Notice positive 2 doesn't work in this case, because if we multiply 2 3 times, we're just going to get positive 8. Awesome. So the reason we started out with these is if we're taking the nth root where the index is even, we're going to get a positive and negative solution. If we take the nth root where the index is odd, we're just going to get whatever sign this was. If it's positive, we're going to get a positive. If it's negative, we're going to get a negative. All right, moving on. We're going to get to some more challenging examples here. All right, so we're going to skip part A. We're going to go on to part B. It's a little bit more difficult. Not much, though. All right, so we have 1/2 times the quantity x plus 3 raised to the fourth power. That equals 128. So obviously the end goal here, I always want to figure out what is our end goal. Our end goal is to find the value of x that satisfies this equation or makes it true. All right, in order to do that, we got to strip away some of these parts. All right, so we got to undo these operations in the opposite order that they occurred. All right, if we're thinking about like building this equation here, we start with x, we added 3, and then this quantity gets raised to the fourth power, and then we multiply by 1/2. All right, so to undo it, we just got to do the exact opposite. Okay, so one thing though is we don't want to divide by 1/2. Instead, we're going to multiply by the reciprocal. Oops. So we are going to multiply by 2 on both sides, and that's going to get rid of that 1/2. So now we have 256. Now we're going to take the fourth root, because that's the opposite of raising it to the fourth power. And when we take that fourth root, remember, we yield a positive and a negative solution. Okay, the fourth root of 256 is just 4. So we have positive and negative 4. And then after that, we subtract 3. So we're going to subtract 3 from both 4 and subtract 3 from negative 4. So our two solutions in this case is going to be 1 and negative 7. So just as a brief recap, we undid operations. right? So we took the fourth root. After that, remember that created a positive and negative solution. We wrote down those two equations and solved from there. Cool beans. All right, let's check this one out. Okay, if we're looking at, an SAT style question, a lot of times the reason why we get lower scores on standardized tests like that is because they include a lot of unnecessary information. This might be an example of that. Okay, so maybe you enjoy the real life context of a question like this, but really, if we're thinking about a time test, we just want to get to the solution as fast as possible, and then also in the least confusing manner. So first, if this is like an SAT style question, these are the things that we need to look at. Obviously, also we need to look at what is asked. So it's giving us an equation. It's saying use this value. And then finally, it's saying we want to approximate the surface area of a marmot shown below whose mass is 33.75 grams. All right, so the mass is 33.75, K is 9.3, and we're finding the surface area, which is pretty nice because that's exactly what this equation is talking about. So we have 9.3 times 33.75 raised to the 2/3 power. All right, and we can just type it in. Okay, we could type it in as exactly as shown. A lot of times I like to use parentheses instead. Okay, so this is how I would type it in. Now, depending on what kind of calculator you're using, if you're using your phone in particular, you've got to first take this number, raise it to the 2/3 power, and then multiply by 9.3, if I'm not mistaken. It depends what kind of phone you have. I have an Android, so that might be a little bit different. All right, so if we do this, we get 97.13 centimeters squared, okay, as the surface area of the marmot. Awesome, folks. So that's it. If you have any questions, make sure to email me. If you enjoyed this or found this helpful, like, subscribe, and share. Thank you, and have a great day.